All right. Welcome to the final day of the Metasploit Advanced Next Level Metasploit class. I want to thank you guys for everything that we've been doing so far. It's been a pretty good week. So this time, we're going to jump down into our Windows 7 virtual machine. I want you guys to really start being introduced to the concept of writing an exploit and what's the process that an attacker goes through when he does build an exploit. So what we're going to do is inside of our Windows 7 machine, we're going to go to the same paste bin. So here's the same paste bin file that we've been using. And now I'd like you to go down to number 1604. Okay. So here's the file that I want you to download. Okay. So we're going to download this file. Now sometimes when you copy inside of Internet Explorer, it actually copies the line number. So I'm going to open up a new tab and try to download the file. Did you guys see what I mean? Sometimes it copies the line number.
Yep.
So I'm just going to delete the line number and the period and download the file. Okay. Now when you download the file, I'm going to extract it to the desktop. So when I extracted it to the desktop, I extracted it all to a folder called Exploit Lab. Okay. So can you guys just let me know when you got that going and when we're all good to go, and then we'll move on, okay?
Okay. Doing the extraction now.
All right.
Okay. Extract it.
All right.
Good to go, Alexander? Good to go, Rollin?
Yes. Good to go.
Yeah.
All right. We're in there like swimwear, fellas. Yeah. Rollin, I got your email about the PowerShell. We'll work it out, buddy, okay?
Oh, certainly. Not a problem. That was just a question.
No problem, man. I got your back.
Thank
Okay.
you.
Okay, guys. So what we have in this folder, I'm going to open up this folder, and you're going to see in the folder it's got a few things. Now, I got the folder just in case you want to do this on a different virtual machine. Now, I don't really recommend doing this on your main computer. You can. You certainly can. Like, if you wanted to download this link and do it on another computer, you certainly can. But, you know, again, I just think it's a little bit better to do this kind of stuff inside of a virtual machine. So your first folder is going to be the software to install. Now, since we're in the virtual machine, we don't need to install any of the software. It's already installed. But just to give you a quick tour, in here we're going to have Notepad++, Python, and Renoir. So Python is for Windows, and it's because the scripts that we're using are in Python. They're not Ruby scripts. We've been in Ruby all week. But for conceptually understanding exploits, Python is fine. Okay, the second folder is a folder called Bone Server. Bone Server is a piece of software that's exploitable. So it's a piece of vulnerable software. So can you guys go into that folder for me, please?
Yes. I'm there.
Okay. Now, what I'd like for you to do is you find the Bone Server exe. I'd like you to right-click on it and choose the option Send to Desktop Create Shortcut.
Okay.
Okay, can you do that for me?
Done.
Okay, so that should create a shortcut to this vulnerable software.
Mm-hmm.
Okay, when you open it up, it should look kind of like a command prompt. Okay, can you start it and double click it? Does it open up like this for you guys?
Yes. Waiting for client connection.
Great, great. Okay, so we'll leave that open for right now. Okay, let's go up a directory, and now we should have another directory called OllyDBT. Do you guys have that as well?
Yes.
Okay, so we'll go in here. We'll go in here, and you should have what looks like a red splat. I'd like you to do the same thing. Send to desktop create shortcut.
Yep. Done.
Okay?
Mm-hmm.
Okay, now what that's going to do is that's going to give us these two shortcuts for what we'll primarily be working on.
Mm-hmm.
Okay. Okay, I'm just going to go through this really quickly. Okay, so we're going to have to digress just a tiny bit, but I'll make sure it's fast, okay?
Mm-hmm.
Okay, let's say we're in a situation where you're running a port scanner or a vulnerability scanner. How many of you guys are familiar with products like Nessus, Qualys, Nexpose, GFI LandGuard, FoundScan, InCircle? Are you guys familiar with these types of products?
I'm familiar with Qualys and Nexus.
Okay. All right, so these products are vulnerability scanning products, right? So
Yes.
as an example, what would happen is, let's say you were trying to attack a machine. What you would do is you would ping sweep. So you ping sweep the network. The reason you ping sweep the network is you want to know what hosts are reachable in the network.
Mm-hmm.
So after you ping sweep the network, you go, okay, these computers are reachable.
Mm-hmm.
Then your next step is going to be to port scan. So after you port scan, you say, okay, these services are available in the network. Then after that, you banner grab. You banner grab so you can get the service version of the running piece of software.
Mm-hmm.
Then you do your exploit research. So this is the typical process
Yeah.
that an attacker goes through.
Yeah, వస్తున్నా.
So I'm going to boot up a machine real quick, and I'll just kind of walk through it real fast.
Okay.
So you don't need to do this. I'm just doing this just so I can explain to you guys.
వస్తున్నాను.
Okay,
వస్తున్నాను.
so if we have that process, What does that process look like? You're going to pin sweep, you're going to port scan, you're going to banner grab, you're going to do your vulnerability research. So here's some options for ways that you can pin sweep. You can tell Nmap to ping every host in the whole subnet. The hosts that come back alive are the hosts that are reachable. After that, what you're going to do is you're probably going to try to port scan. Now, you can just use like a default scan, or you can say, hey, I want to scan for a specific list of ports. So do you see here I'm giving it a list of ports? I want you to scan for FTP. I want you to scan for Telnet. I want you to scan for SMTP, right? Web, proxy. 1433 is MS SQL Server, right? The Microsoft SQL Server. 1521 is Oracle. 3306 is MySQL. After that, what you can do is you can banner grab. A banner grab is going to be a connection to the port where you're trying to see what version of the service it's running. It's one thing to know that the service is running FTP, but the real critical thing is what version of FTP. So let's look at this process. Let's nmap s capital P 192.168.10.130. Okay, so is the host alive?
It's up.
Okay, so the host is up. That's the ping sweep, right? I need to know, is the host reachable? Now the next step, if we go back to our process, okay, if our first step is ping sweep, what's our next step?
Port scan.
There you go. Port scan is our next step. Good job. So if we look at port scan, right now I'm doing port scan. Okay. So the lowercase s is telling you do a scan, and then the capital S is telling you the scan type. So right now, we ran this port scan. You guys see a list of open ports?
Yep.
Okay. What I find with a lot of my students is you'll say something to them. They'll say like, oh yeah, I've been in an environment and we ran some Nmap scans. And then when you sit next to the person and they run the Nmap scans, you can kind of see like they look at the ports and then they kind of say to themselves like, now what? You know, like, okay, I see ports. Now what? And, you know, you just have to kind of realize like, okay, step one was, can I talk to it? Ping sweep. Step two is what services are running. So in this case, let's take a look. In this case, port 80 is open. So port 80 is for web, so it's a web server. 135, 135, 139, 445, and 1025. These are pretty good indicators that it's a Windows machine. It could possibly be a Linux machine running Samba, but most likely this is a Windows machine. 445 especially lets us know that it's a Windows host, Windows 2000 and above. Okay, that's called Windows Directory Services. Okay, so Win2K and above, right? Letting you know, and higher. Okay, then when we saw 1433, what's this?
Oh, SQL.
Yeah.
SQL.
Okay, now, can you guys tell me what's the difference between a DMZ and the LAN? What's the difference between a DMZ and a LAN?
Is that the DMC are so like extranet outside the LAN perimeters.
Uh-huh.
It is within though, but it's divided by a firewall.
There you go.
Hmm.
There you go.
Hmm.
So, what types of servers would be in the DMZ?
Web servers.
There you go. Good job, Alexander. Web servers will
Hmm.
most likely be in the DMZ. So
Something that.
what if you did a port scan, and in the port scan of the whole subnet, you saw 30 web servers? Is that most likely the LAN, or is that most likely the DMZ?
DMZ.
That's most likely the DMZ, right?
Yeah.
Okay. What if you're port scanning and you see port 389? 389.
But that is LDAP.
That is LDAP. Good job.
Mm-hmm.
So LDAP is most likely your domain controller.
Mm-hmm.
So that's probably not going to be in the LAN. It's probably not going to be in the DMZ. It's probably going to be in the LAN, right?
Correct. Mm-hmm.
Okay. Now what if I see port 5060, right?
Mm-hmm.
Now what if I see 100 machines running port 5060?
That is DNS, no?
No, no, my friend.
Oh, voice air. Okay, voice over IP. That's right.
Right. So that's probably the voice VLAN.
Mm-hmm.
You understand?
Right.
Now, when an attacker is attacking your network, he doesn't have, or at least hopefully he doesn't have, he doesn't have your Visio, does he?
Mm-hmm.
So we use the ports that we find open to help us map the network.
Mm-hmm.
Thus, the name of the tool, what?
And now.
Short for network map.
Mm-hmm.
So based on the ports that are open, you can figure out what it is. If you see two
Mm-hmm.
machines running port 53, that's DNS servers, right?
Mm-hmm.
So you go, okay, so those are DNS servers, they're in this subnet. Okay, these are workstations, they're in that subnet. Make sense,
Mm-hmm.
guys?
Right.
So you use the ports that are open to figure out where stuff is and what it is. This
Mm-hmm.
is how you map the network. Now we're going to do it a little different. We're going to do the next step, and the next step is called a banner grab. Okay, so our first step was what, guys?
That was to pin sweep
Okay, now why do you ping sweep? What are you trying to figure out?
to see what is on what's
And we talk to host.
yeah, the
Exactly,
hosts are
what's
up.
reachable.
Mm-hmm.
Okay, then when you did your port scan, what are you trying to learn right here?
What services are running?
Exactly, what services are running. Very, very good. Very, very good. Now here we've done our banner grab. It looks like a port scan, doesn't it?
Yep.
But what do you notice?
Version of services.
There you
Using
go.
IIS. Mm-hmm.
So for each service, what can you see?
the version of the service equal
Right.
3005.
That's a banner grab. You understand?
Right.
So now that you've got your banner grab, you can say, okay, it's not important to me that it's FTP. It's important to me that it's this version of FTP. It's not important to me that it's an SQL server. It's important to me that it's this version of SQL server. If you see some software and it's version 2.1 versus version 2.3, which one is newer?
2.1.
No. Which one is the newer piece of software?
Oh,
2.3.
sorry. 2.3.
Yeah, the 2.3 is the newer piece of software. It's much more updated, right?
Right. Yep.
So, and the vulnerabilities are usually assigned to the version of the software, right?
Right.
So this piece of software, this version number is vulnerable. So if they tell you 2.1 is vulnerable, then 2.3 is probably the fix. Yeah?
Right.
So this is what you're looking for when you're banner grabbing. That's what you're looking for. You want to go, okay, is that particular version of the software vulnerable? So your next step is to take the banner and look it up here. Does this make sense, guys?
Makes sense. Yep.
So these are websites where you can look up exploits for a particular version of software.
Mm-hmm.
So you say, okay, I want to go to one of these websites. So I'm going to go to securityfocus.com/BID as an example, right? And then I want to choose my vendor. The vendor I want to choose is Microsoft. Did I miss it?
No, it just show the Microsoft. Oh, down below.
There we go.
Mm-hmm.
So that's the vendor. Okay. After I get the vendor, I need to choose the product.
Mm-hmm.
So in this case, let me choose IIS. Okay.
Mm-hmm.
So as we look at this, it's Microsoft. What?
IS
What's the version?
6.0.
You see?
Mm.
Okay. So now that I've done that, everything here is all vulnerabilities for IIS version 6.0.
Mm-hmm.
This makes sense why you do it this way, guys?
Yep.
So you read through them and you try to look for something that might be applicable to you. So, here's a buffer overflow, right?
Mm-hmm.
So I go to that, and you're going to see it's going to have a number. We call this a BID number, bug track identifier, right? So the bug track identifier, in this case 36189, will always correlate to a CVE number, common vulnerability and exposure, most of the times in the security industry, we don't use the bug track IDs. We usually use the CVEs. Okay, the CVE is almost always going to have the year and then the number in which it was categorized by cert.org. Okay, now here they give us the breakdown if it's a remote exploit or if it's a local exploit. In this case, it's a what exploit, guys?
Remote.
Remote.
It's remote. Now I can click here and I can get some information about it, right? It's prone to a stack buffer overflow affecting the server's FTP server. Yeah? And now if I click exploit, what do you notice right here, guys?
Oh, wow.
What are they giving me?
The exploits himself.
Say what, guys?
The exploits himself. I mean, like.
Yeah, they give you actual exploits. You see? So you can do this on each of these websites, right? So you ping sweep so you can figure out what version of, what's alive. You port scan so that you can figure out what services are running. You banner grab so you can get the version of the service. Then you look up the version of the service in one of these three websites to see if there's an exploit for it. And then you launch the exploit, right? That's the typical attack process. Now, there is no spoon, Neo. Now let me see if you guys can put together what I'm showing you now. What is the process that each of these tools uses? Is this making sense?
That's right. Yeah.
When you run a vulnerability scanner, it does all of these steps.
So that ping sweep, port scan, banner grabbing. Yep.
Does that make sense?
Makes sense. Yep.
So when the scanner starts and it tells you it's doing its host discovery, what's it doing?
Doing the ping sweep. Yep.
Uh-huh. When the scanner is running and it's telling you that it's doing its host enumeration, what's it doing?
Identifying the services.
Uh-huh.
Scan.
There you go. So then after that, as it starts to do vulnerability identification, what's it doing?
Identifying the specific version of software.
Metasploit.
Then it downloads the same databases that I just showed you, right? And it does what?
Research.
Uh-huh.
Correlating that to those databases.
Does this make sense?
Makes sense.
Now, what if someone says, hey, Rollin, hey, Alexander, I need you to validate false positives, right? I need you to take the scan result and validate the false positives. Can you now go through this process here to see if the scanner is correct?
Mm-hmm.
Do you understand now how you validate false positives?
Right.
So if the host is running like a local firewall, will the ping sweep results, is it possible that they may be incorrect?
Yep.
Is it possible that the port scan results may be incorrect?
Right.
So if the port scan results are incorrect, that feeds the wrong data into what step?
The bandit grabbing.
Which feeds the wrong data into what step?
The research.
Which causes the false positives. Does this make sense?
Makes sense.
So you could be in a situation where there's host-based firewalls, there's network filtering, there's antivirus, there's something in the environment that's causing the scanner to misread what it's seeing.
Mm-hmm.
And that's what skews the results of the scanner. That's what causes false positives.
Mm-hmm.
Okay, scanners look for known vulnerabilities. Known vulnerabilities. In other words, version 1.2.3 of this software has a problem. So when someone says, hey, we got a brand new server, I want you to test this brand new server. If you run Nessus, Qualys, Nexpose, if you run these types of things against the server, you're looking for known vulnerabilities,
Mm-hmm.
right?
Right.
What if your software development group made a new piece of software yesterday?
Mm-hmm.
When you run these scanners against it, are the scanners going to find anything?
No.
No, right? Because there's no known vulnerabilities in the product. Does that make sense, guys?
Yep.
So that's what this exploit development process is for. So I know that's really long-winded, and I'm sorry it took so long, but I have to kind of bring you up to this process now, right?
Mm-hmm. No.
So
Good stuff.
now let's say we have this application running. Remember we got this thing going?
Mm-hmm.
Okay. I want you to open a command prompt. Okay, we have a command prompt. So you have a regular command prompt that you just opened, and you have the Vuln server application. Okay, can you guys do that?
Mm-hmm.
Okay.
Okay, I want you to type netcat nc 127.0.0.1 port 9999. Okay, then press enter.
Okay. Naked. 127.
Let's try localhost. What the heck?
Worked for me.
Huh?
I get a message say welcome to the vulnerable server. Enter help for help.
Yeah, that's
Oh.
exactly what it's supposed to do.
Mm-hmm.
That's weird. I've seen that before. Hmm. Okay. Well, let's try it here. Yeah, there you go.
Mm-hmm.
Weird. I have no idea why I did that on my machine. I'll have to look at that later. Okay, did that work for you guys? Where it looks like this?
Mm-hmm.
Yes.
Okay. Now here, do you see the application said it received a connection?
Mm-hmm.
You guys got that?
Yep.
Yep.
Okay. So why is this important? let's say someone gives you a brand new app. So your dev team produces a brand new app. Now the app can be standalone, the app can be client server, or the app can be a web app. So if it's standalone, this would be an example of like MS Word, something that runs on your local machine, but you don't connect to it over a logical port, right?
Mm-hmm.
But what if the app is like an FTP server, right? That's what kind of software?
Mm-hmm.
It's client server software. Does that make sense, guys?
Right, makes sense.
So what's happening, or if it's a web app, it's a website, right? So these kinds, they consume file or keyboard input.
Mm-hmm.
Okay, is this making sense?
Yes.
So if someone gives you a standalone server, a standalone file, a standalone program, usually the way that you exploit it is you have to make it consume a file. Like if it's Adobe Acrobat, the way you hack Adobe Acrobat is you send a malicious PDF, right?
Mm-hmm.
Since it's a standalone app, you make it consume a malicious file. If you're attacking a server, the server is going to have a client that talks to it, right? And then the server is going to receive that malicious input over the network. The web app is going to receive that malicious input via the browser. So no matter what, when you're attacking something, you have to figure out, how do I talk to it?
Mm-hmm.
Do you see what you have to figure out?
Right.
So your dev team comes to you and they say, hey, Rowland, hey, Alexander, hey, Uma, we just developed a brand new application. Can you security test it? What
Mm-hmm.
most people do is they run their vulnerability scanner against it,
Mm-hmm.
right?
Right.
They go, oh, you developed the application yesterday? Let me scan it with Nessus, right?
Mm-hmm.
They scan it with Nessus. They go, okay, application looks good, right?
Mm-hmm.
But now that you guys see the context, is that really the right way to go about it?
Nope.
Yeah, that's probably not the best thing to do. It's certainly not a bad thing to do, right? You want to
Mm-hmm.
see that they build the application using vulnerable components, but we still need to test for unknown vulnerabilities as well.
Mm-hmm.
Okay, so for each one, now what we want to do is we want to do a process called fuzzing.
Mm-hmm.
So you need to enumerate the application entry points. Okay, now that's a lot of mumbo jumbo, huh? How do you enumerate application entry points?
Mm-hmm.
Okay, so right here, he told you enter what?
enter, yep, welcome to vulnerable server. Enter help for help.
Okay, so type help. Okay. So he says, hey, here's my list of what?
Valid commands.
Okay. The valid commands are the entry points to the application. Okay. So we saw that when we talk to this thing, we talk to it on what port?
99999.
Okay. So quadruple 9, that's the port we talk to it on. The entry points after connecting to port 9999 are what?
All of those.
This list of commands. So what you want to do is you want to connect to the app and you want to say help and then blah. You want to say stats and then blah. R time and then blah. L time and then what? Go ahead,
Blah.
say it. Blah. Right?
Yeah.
Okay. Now what we want to do is the application is expecting some sort of value, right? And we just want to send it a bunch of garbage. In other words, we want to send it a bunch of invalid data to that particular command. Now, just so that you can understand, guys, this process is called what?
Fuzzing.
Fuzzing. For the entry points to the application, you want to send as much invalid data to that entry point as possible to see what the application does. Does the application misbehave in a way? Does the application misbehave in a way that'll allow you to take control of it? So what we want to do what I want you guys to do is I want you to go into folder number 4. So folder number 4, attack scripts. Okay, I want you to right click on Simple Fuzzer and edit with Notepad++. Okay, does that work for you guys?
Yep.
Right click on Simple Fuzzer, edit with Notepad++, okay?
Okay.
Okay, so it opens up this script, right? Okay, now what we want to do, we want to look at this script. Line 1 is the interpreter. You've got two types of code in our world. You've got compiled code, and then you have interpreted code. Interpreted code is just a text file, where the first line of the code is the interpreter. But can you see how this is just a text file? But the first line is the interpreter. In other words, it tells you when you run me, use this. So the interpreter will be bin bash, or user bin Perl, or user bin Python, or user bin Ruby. Okay? So this is interpreted code. Compiled code is an exe. When we run PuTTY, for example, PuTTY is just a what? What kind of file is it?
EXE.
Executable.
It's an exe. An exe does not require an interpreter to run, right? You just double click on it and run it, okay? Some people call it native code, right? It's ready to run. It's ready to work. It's not interpreted. You don't need an interpreter, okay? So line 1 is your interpreter. Line 2 is your module. Okay. Now we're going to create a list called buffer. So I want you guys just to see if we can figure this out. Buffer's value is what?
A.
A. Good. Counter's value is what?
50.
50. Now, what we're going to say is, while the what?
Length of a buffer.
Yeah, while the length of the buffer,
Length.
right, is less than or equal to what?
100.
100, I want you to do something. And we want to append, right, A times what?
Counter.
Counter. Right? So if you're in a situation where you go, okay, if I go A, right, times 50, I get what?
58, sir.
I get 58s, right? So if I go, buffer, right, equals A, then I go counter equals what? What does counter equal?
50.
50.
Okay, now I say counter equals 50. If I turn around and I say while the length of buffer is less than or equal to 100, you see how it gives me these dots? These dots let me know that I need to tab over. Okay? All right, after that, you're gonna append 50 to this list. Now, if I go counter's value is what, guys?
Counter value is
50.
50
50, and I go counter plus 50. That's 50 plus what?
plus 50.
Plus 50. Okay, we just created, it's called a while loop. So if we look at this, the first time through buffer, buffer's value was what?
A.
8.
The second time through buffer's value was what?
50.
50 A's.
50 A's, right? The next time through buffer's value is what?
100 A's.
You starting to see what's going on, guys?
Yep.
As we keep iterating through the buffer, that list of A's keeps doing what?
Keeps adding up.
Yeah, it's getting crazy, huh? Now, what if we wanted to go really crazy? What about the 99th time through buffer, huh? Right?
Bye-bye, server.
Yeah, bye-bye server. That's the goal, right? Okay. Now, if we look down here on line 16, now we have a list of what?
Commands.
Do these look familiar?
Yep.
These look like those same commands, huh?
Yep.
Are they the same ones?
Yeah.
Uh-huh. Okay. So now what you're saying is, for each command in commands, for each command in my list of commands, and for each of the characters in buffer, right? So the first time when it's A, the second time when it's 50 A's, the third time when it's 100 A's, for each, we're going to call that a character. For each one of those in buffer, I want you to print what?
Fuzzing.
Fuzzing, and then you're going to say the command name, and then I want you to tell me how many A's you're sending. Right? Print the length of the characters as a string. Okay? Now, I want to create a socket. Socket.socket. Socket AF is address family. INET is internet. socket.sock stream is TCP.
Mm.
Now, if it were socket.sock underscore dgram,
UDP.
that would be UDP. Okay? Now he's going to make all of this stuff equal what?
S.
S, because I don't want to type all that gobbledygook again. Yeah?
Yep.
Yeah.
Yep.
Yeah. When you learn to program, you have to focus on one very important word. Okay?
Lazy.
Yeah. We're efficient. That's what we are. Okay. So now I can S dot what?
Connect.
So I can connect to localhost port.
999. Mm-hmm.
Okay. When I connect, I'm going to get a message back that says, welcome to vulnerable server. What do I need to do with that message?
Press help.
Huh?
Oh,
Receive.
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 There you go. So now that message is like 70, 75 characters. So I'm lazy, so I just made what?
100. Mm-hmm.
Yeah, just receive, about 100 characters or so. Then I'm going to s.send, and what am I sending?
The commands. Mm-hmm.
The command,
Mm-hmm.
and the what?
And plus the characters.
And the characters. And then after that, I do what?
Close it.
So if we have our vulnerable application running,
Mm-hmm.
okay, do you have your vulnerable application running?
Yep.
Okay, I want you to go to the folder where you see Simple Fuzzer. Okay, you should have your vulnerable application running, and you should be able to see Simple Fuzzer.
Yep.
Now double click on Simple Fuzzer. See how it goes crazy?
Yeah.
Now what did it do to your application?
Crashed it.
Yeah, it crashed it. Now, who's like, this is exactly what I want to do in security, because I'd much rather break stuff than fix it, yeah? Okay.
Joe,
Yes,
quick
my
question. In that command line, why do you have the dot? You didn't have it for help, but we had it for return dot. Why do we have those dots at the end?
Oh, my friend, you're such an astute person. Good one, Uma. All right. So here's the question that Uma asked. He says, hey, Joe, how come sometimes you have a dot? You see how some of these have a dot?
Mm.
And some of them don't?
Right.
So
Oh.
the simple answer is it just crashes better. That's just the honest to God truth, right? Because when I first wrote this, I wrote it without the period, and it would crash, but it wouldn't crash as badly, right? So there's these different things that you have to do on the internet, right? They're hacking challenges. And some of these hacking challenges, the only way that you can make the server crash is to send it like, 11 squigglies. You guys familiar with like the squiggly character, right?
Mm-hmm.
Right? So you do. So like for some reason, it only crashed really well if you sent it this plus your fuzz string of the A's. Right? These are those kinds of things where at the end of the day, because you're dealing with unknown software, right? Different things are going to make different pieces of software behave differently, right? Because what's happening is your application is consuming this data and it's trying to act upon the data. So maybe, for example, your application thinks a colon is a field delimiter, right? Is that possible?
Right. Yep.
Your application may think that if I see a colon, that's a field delimiter, right? He may think a semicolon is the termination of a command,
Mm-hmm.
right? He may think, you know, a set of brackets. He may think it's a logical operator, meaning don't do something, right? Like
Right.
not equal to.
Mm-hmm.
So what happens is when you're trying to fuzz an application, this is what we talked about. You send input to the application that the application does not expect. The more reliably we can make the application crash, the better we can understand it. Because when it crashes, the error messages become the breadcrumbs, right? That becomes the hints that we follow so we can learn how the application works. Like while the application is just sitting here as an exe, there's very little I can learn about it, right?
Mm-hmm. Right.
But when you poke at it and it keeps spewing errors, that's when you can learn. Uma, good job. Very astute, my friend.
Thank you.
Uma, you're teaching next week, buddy.
That's it. We in it.
Okay, so we got our app to crash, right?
Mm-hmm.
Now, what I'd like for you guys to do is I'm going to rerun the vulnerable server. Okay, go ahead and close it all up. Reopen the vulnerable server. You guys got it back open?
Okay, so close.
Yep.
Not yet. Hang on. What do we have to do? Yep.
Okay, so we got our vulnerable server back going.
Mm-hmm.
Okay, I want you to go back to the directory with your lab.
Mm-hmm.
With your scripts. And I want you to rerun the simple fuzzer again. Can you guys rerun it again for me?
Yep.
Okay, so I'm going to rerun mine again. Now it crashed again. This time,
Yep.
I want you guys to give me the number of where it crashes. Where did it crash?
It crashed at 4700.
Okay. What
Mine
command?
didn't crash.
Huh?
The command for me is HTER.
Okay, so yours crashed on hter. So hter, what number?
4700.
Okay, I got an hter 4700. Okay, I got a T-run for me. For me, T-run 4200. Okay, Alexander, how about you, buddy?
2300.
Of what command?
Tran
What's the number?
2300.
2300. Okay.
Yep.
Okay. Let's do it again, guys. Close it up, restart it.
Okay.
Okay, I rerun mine. Okay, mine, T-run 3650 for me.
Mine Tron 2300.
Okay. 2300 two times. 3650. What else?
Tran 2250.
2250.
Tran 2250. Yep.
Okay. All right, let's do it
2250.
again, guys. Let's do it again.
Okay.
Okay, I'll run my fuzzer again. Okay, I got T-run 3450 for me.
Got T1 2350 for me.
Tron 2850.
Okay, where would you say it's crashing at the most, guys?
At
Which command is it crashing at the most?
Tron
Tron.
T1.
Yeah, T-run, yeah?
Yeah, Tron.
All right, now the best thing in the world to do is to go to a developer and say that you have irregular, non-reproducible results. They love that, don't they?
Mm-hmm.
Sometimes your app crashes here, sometimes it crashes here. And it's really hard for me to reproduce. Can you fix that? Right? Developers love that, don't they? Okay, so let's try something, guys. I want you guys to try something.
Mm-hmm.
Okay, I want you to restart your vulnerable server. You got it running?
Yep. Close that. Starting. Yep.
Okay. Now, what I want you to go to is I want you to go to that red splat called Ollie Debug. Okay, we open up Ollie Debug. Okay, and just be a user. You don't need to read any error messages. Feels good, doesn't it?
Yeah.
Ignorance is bliss, huh? Do you guys have family members that do that? Like they ask you questions, but they don't read the error messages?
Yep.
Right? They're like, hey, I got this error on my computer. And you're like, what error? You're like, I don't know, I just clicked it. Kind of like, oh, thanks. Okay, do you guys have Ollie Debug open?
Yeah. A quick question. What is the difference between immunity and the Ali debugger? It's just different type because what's his name on that videos last night was using immunity.
Ollie Debug was purchased by Immunity and the interface was just changed a little bit. It's literally the same debugger.
Oh, I see. Okay.
Okay, so we got our debugger going, yeah?
Mm-hmm.
Okay, what I want you to do is hit File in the top corner and choose Attach. File in the top corner and choose Attach.
Mm-hmm.
Excuse me. Okay, do you guys see vulnerable server in here?
Yep.
Okay, we want to attach to it. Okay, when I did that, how many of you guys noticed in the bottom it says paused?
Yes.
Excuse me. Okay, what we want to do is go up here
Mm-hmm.
and hit your play button 2 times. So I hit my play button 2 times. What does it say down here now?
Now it's running.
Now it's running.
Mm-hmm.
Okay, go back to your folder and double click the simple fuzzer. Ooh, allergies. Okay, so just like you, I'm going to rerun my simple fuzzer.
Mm-hmm.
Okay, mine crashed. Where did yours crash?
2100. E1 2100.
Same.
Okay. Okay, so now what I want you guys to do in your debugger, go up here. Okay, I want you to choose debug, restart. Go ahead. Debug, restart. Did it restart?
Yep.
Okay, you might have to say okay. Now it still says paused for me. What do you do when it says paused?
Press it again. Play it again.
Yeah, hit play how many times?
Twice.
Yeah, so I hit play 2 times. Now my debugger says what?
Running.
Running. Okay, what I want you to do, run your simple fuzzer again.
T1 2100.
Same.
I got T-Run 2100 as well. So what are you guys noticing once we put it in the debugger?
You know, just give it specific. What is it that it is running? I mean, what it says. I mean, filing.
Yeah, when we weren't running it in the debugger, what were we getting?
Just different.
Different.
different result.
Yeah, it was really kind of hard to isolate the crash when we weren't in a debugger. Once we got in the debugger, what?
Now we get more specific.
Yeah, very easy to isolate the exact point where it crashes. Okay, so this is really important for us. We now know that when I send 2,100 A's to the application, it crashes, huh?
Mm-hmm.
Now, I want you guys to look over here, okay, in the top right corner, okay? This area, we call these registers. Now, I want you to look for your A's. Do you see your A's?
Oh.
You see them?
Yep.
Yep.
You see them?
Mm-hmm.
So where do you see your A's? What register do you see them in?
AES and ESP.
Good job. So any register that you can write to is a register that you're going to say you control. So you'll hear people say, oh, I have control of EAX, right? I have control of ESP. And what does that mean? What were they able to do?
Be able to fill it up. I mean, fill out the memory, that space.
Exactly. They were able to write to that area of the processor. Okay? Now we want to
what AES stand for?
EAX stands for the accumulator register. So like ESP is the extended stack pointer, right?
Okay.
EIP is the extended instruction pointer. EBP is like the extended base pointer. ESI is the extended stack index. But we'll get to that in a second. Okay, so I'm looking at an ASCII table, right? And in hexadecimal, in hexadecimal, 41 in hex is a what?
It's a letter A, capital.
So, what are these?
A's in hexadecimal.
A's written in hexadecimal. Good job. So now if I ask you what registers you control, you would say, I control what?
Letter A's.
But call out the registers you control.
You got ESP,
Uh-huh.
EAS,
Uh-huh.
EBP,
Good. And?
and EIP.
Good. These are the registers that you control.
Mm-hmm.
Okay? So these are the registers that you control. So now you say, okay, I want to debug and restart. Debug and restart. Okay, now my debugger says paused. What do I do? When I debug and restart, my debugger says paused. What do I do?
Press it 2 times.
Press what?
Press it 2 times. Mm-hmm.
There you go. Press play 2 times. Okay, now my debugger says what?
Running.
Good job. Very good job. Okay, so now we see that my debugger says running. I want you to go back to your folder with the scripts. We're going to right-click on script number 2, and we're going to edit it with Notepad++. Okay? How is this script different from the first one? Can anyone tell me?
Have 3,000 A's.
You're running only against one command.
There you go, Uma. Uma, I told you you're teaching next week, buddy. Okay? So, Alexander's correct. We're sending how many A's?
3,000.
3,000 A's, and Uma's correct. We're only running it against what?
Turn.
Yeah.
Right. So we call this step isolating the crash. We call this step isolating the crash. We want to just figure out if I just send stuff to the trun function, does it still crash the same way? So you always check, does your debugger say running?
Yes.
Okay, so my debugger says running. My debugger says running. So what I'm going to do is I'm going to double click on script 2. I double click on script 2. Let's check my registers. Do I still have control of the same registers?
Mm-hmm.
I still control EAX.
Yes.
I still control ESP.
EBP.
I still control EBP. Good job. And I still control what?
EIP.
EIP. Very good. Very good. Okay. So now I want to debug and what, guys?
And restart.
And restart. And then my debugger says pause, so what do?
Press play 2 times.
I hit play 2 times. Good job. That gets my debugger back to running. Okay. Now, we need to know something. EIP, the extended instruction pointer, is what is about to happen next. Okay, that's not the technical definition of what EIP is, but the simplest way to understand the instruction pointer is whatever is in EIP, that's what's about to run. So if I run this script, you guys don't need to, but I'll do it again. If I run this script, you're going to see down on the bottom, he says access violation when executing. 4141414141. In other words, hey man, I don't know how to run what?
4141.
I don't know how to run that.
Right.
So whatever's in EIP, that's what he's trying to execute. He's trying to run that, and it's not running. It's causing the application to crash because he's like, I don't know how to run that. So that's the reason that we send it garbage, because now we can go, okay, that's the point that the computer's trying to execute. So now somewhere in 3,000 A's, because you remember that's what we sent, right?
Mm-hmm.
Somewhere in 3,000 A's is EIP.
Mm.
Right? So he sent all these A's. Somewhere in there is EIP.
Mm.
The trick is, where is it?
Right.
Right?
Mm-hmm.
Because what you really want to do, since EIP is what's about to run next, what you want to do is you want to count. Let's say it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I want to send that many A's, 27 A's, and I want to put malware here.
Mm.
Why do I want to do that? Because EIP is what's about to happen, what?
What's next? What is going to execute next? Mm.
Right. So now that I know, hey, that's the execution point, I want to stick my malware there. Does this make sense, guys?
Makes sense. Yeah.
Because I want the computer to run this code for me. Right? I don't want it to crash.
Right.
I wanted to run my code. So we need to calculate the distance to EIP.
Mm-hmm.
This makes sense?
Yep.
That's what you're trying to do right now. I need to know my distance to EIP. So I want you guys to look at script number 3. Edit script number 3 with Notepad++.
Okay.
What do you notice we did in that one? What's the difference between script number 2 and script number 3?
Non-repeating character.
Uh-huh. So if I look at this script, it's what?
Yeah, it's just yeah, at 3,000 characters. Yeah.
If I look at this script, it's what?
Non-repeating characters.
Non-repeating characters.
Right.
Yep.
Where is pattern set up? Where is it at now? Should be under tools, right? Tools, it's under exploit now. Okay. I'm inside of the Metasploit folder. You guys don't need to do this, but just so you understand how this is created, inside of Metasploit, they moved it. It used to be under the tools folder, but now they moved it under tools exploit. So I'm going to say Ruby pattern create 200. Whoops. Pattern create.rb 200. And when I did that, what do you notice it built me?
Mm-hmm. Non-repeating characters.
Yeah, it built me how many non-repeating characters?
Mm-hmm.
200.
Okay. So are you seeing how we generate that? Hey, Metasploit, I need 3,000 non-repeating characters. This is where that comes from. You see?
Mhm.
Okay. So do you have your debugger running?
Yes.
Okay, so now what I'm going to do is we're going to double click on script number what, guys?
Number 3.
Okay, we double click on script number 3, and we want to go look in our debugger. What do we have in EIP?
Okay, hang on a second. Let me restart my debugger. And launch 300. Okay.
Yeah, 396F4338.
Is that what you guys have?
Mm-hmm.
So if I go and I grab that ASCII chart, okay, so what's my first number? 39?
39.
So if I get a 39 in hexadecimal, that's what number?
9. Mm-hmm.
9. So 39 is a 9. Okay, what's a 6F in hexadecimal? Here's
6F is
6F.
O.
It's a lowercase o. Okay, now if 41 is the letter A, 42 is the letter B,
See.
then that's a C. Good job.
C. Mm-hmm.
Okay. Then I need a 38 in hexadecimal. That's what?
8.
8.
8. 8. Oops. Okay. Now the only thing that we need to remember is this is backwards. Really what it is 8 C O 9. Right? It's backwards. It's backwards because of an architecture called what, guys?
Little Indian.
Little Indian. It's a matter of how you want to store numbers. Do you want to store numbers reading from left to right, or do you want to store numbers reading from right to left? In our case, we read from right to left, right? So 8 C O 9 is what we're looking for. Okay? So in this script, if I do a control F and I look for 8C09, I'm just saying, hey, do I have it? It's probably, whoops, lowercase o. 8C09, and he found it.
Mm.
You see?
Yep.
So what I'm going to do is I'm going to go right to here. And I'm going to calculate from the start right to here, because this is what?
Yeah, yeah.
Uh-huh.
EAP, yep.
So from 0 to right here is my distance to what?
Execute a command.
That's my distance to EIP. Okay. Now Metasploit has a trick you can use. Let's do it in Python first. I want you guys to right click and edit script number 4 with what?
Number 4 with that is with Notepad.
What do you edit it with, guys?
Notepad plus.
Notepad++.
Notepad. Yep. Mm-hmm.
Okay. So do you see here that we went all the way to 8C09 and then we cut it off? Do you see that?
Mm-hmm.
And then we just said print the what?
Non-repeating characters.
Now that we have done what to it?
You cut it, you comment
Yep,
it.
cut it off.
Mm-hmm.
So you want to print the link to it now that you've cut it off.
Mm-hmm.
Right? So there's going to be a number that'll be in the middle of this box when you run it. Go ahead and run script number 4.
Okay.
What's
the number that you get?
2006.
2006 characters.
2006 characters. Wow.
Okay. So that's our distance to EIP. Metasploit has a tool called pattern offset, where you take that number that you saw in EIP and you just paste it in this way. And Metasploit says what?
2006.
Does this make sense, guys?
Yep.
So now you know my distance to EIP is what, guys?
Yeah, 2006.
Okay. So I'm going to send 2006 A's and then insert my malware, huh?
Uh-huh.
Yep.
Okay. So what we want to do is let's go look at our next script. We'll edit it with what, guys?
With no++.
We'll edit it with Notepad++. And you'll see here, this is kind of a check, huh? My distance to EIP is going to be what?
2006.
Okay, and then in step number 5, I'm going to do an EIP overwrite with what?
B's.
B.
Okay, and if A's are 41s, B's are what?
42.
42s. I told you, Uma, you're teaching next week. Okay? So we're going to fill up, right, with the T-run, with the distance to EIP. The distance to EIP is how much?
2006.
2006, and then this should overwrite what?
The instruction point, yeah.
The instruction pointer. Okay, and it should overwrite it with what?
B's, 4 B's, yeah.
Okay, so I'll see 42, 42, 42 in EIP, and this will be how I'll check my math. Yeah?
Mm-hmm.
So does your debugger say running?
Yes. Actually, pause, yeah.
Okay, so you debug, restart, then you hit play how many times?
2 times.
2 times. Okay? Alright, so now I'm going to double click and run script 5. Okay?
Okay, so we do a script 5.
Yep, you double click and you run script 5. What do you see in EIP?
$42, $42, $42.
Okay, did our math work?
Yeah.
Our math worked correctly, huh?
Mm-hmm.
Okay. Okay, what we want to do is we want to debug and restart.
Mm-hmm.
Okay, hit play a couple times till it says running. Okay, guys, we've been going a little more than an hour, so normally we would take a break. But we only have 2 scripts left, so let's push through and finish these two scripts, okay?
Okay.
Okay, so normally we take a break every hour, but let me just finish this, okay?
Sounds good.
Okay, so now we got another little issue. Okay, I'm going to rerun script 2 because I want to make a point. Now, if you look here, how many of you guys notice I have A's in EAX, like I can see them? I have A's in ESP.
Right.
I can see them. I don't see my A's in EIP. I don't see my A's in EBP. I see 41s here. You guys notice that?
Right.
Okay. So, literally, that's kind of what I kind of oversimplified what EIP is. EIP is the return from a function. So your program is running, and then your program goes, oh, hey, go run this function. So your computer goes, okay, well, let me put a marker right here where I'm standing. I'll go over and I'll execute my function. When I return from my function and I want to pick up where I left off, that spot is called EIP. So EIP is a location, right? It's not really a container. So it's an address of where to go run what's next.
I see.
So it literally is a pointer. It's not really a physical location, right? And you can see that because you can see that your A's aren't in it, huh?
Right.
Like you look at EAX, you can see stuff in EAX, right? You look at ESP, you can see stuff in ESP. So you can see, okay, well, that's it. Now, EIP is only 4 bytes. Okay. 1, 2, 3, 4 bytes. Now, if I need to stick my malware in there, my malware needs to be pretty freaking small, huh?
Right.
So what are my registers that I control? Can anybody tell me the registers I control?
EAS, ESP, EVP, and EIP.
Now, which registers that I control look like they actually have space?
EAX and ESP.
So EAX has space, and ESP has space.
Correct.
So what if instead of 41s right here, I put a jump to what?
To ESP.
And I put that in EIP. The computer would do what?
We'll just jump to that pointer.
Yeah, it would jump over here. So now do I have space to change these A's, and instead of putting A's here, what should I put here?
The malware.
Yeah, you should put the malware here because that's an area that you can write to that has enough space for your malware. Does that make sense?
Yep.
So I need to find a jump ESP instruction. I need to find a jump ESP instruction. Okay, so does everybody have their debugger restarted and running?
I can restart it. Running. Yep.
Okay. Okay, now we're going to do a tiny little trick now. I want you to go in your debugger up to E. Click right there. When I click that E is for executable modules. executable modules. What kind of files do you see running in here?
NewsVLL, all the stuff, and
Okay.
TDL.
So we call these system DLLs. This over here, we call this third-party DLLs. Okay. I need a jump ESP. I have to get the jump ESP from one of these DLLs, right? You have to get your instruction from a DLL that's in memory right now, right? Now, how many of you guys have seen vulnerabilities that say it's for Windows XP Service Pack 3? It's for Windows 7 Service Pack 1. You ever seen that?
Yep.
Okay. If you see that, then what that means is the attacker got his jump ESP from a system DLL. Does that make sense, guys? Because when you apply service packs, what potentially can happen to these DLLs?
They can be override or change.
Yeah, they potentially could change. So if your DLL is from if your jump ESP is from a system DLL, then whatever you wrote the exploit on, the exploit will only work on that target. So right now, if you're inside of your virtual machine, you're in Windows 7. If you use a system DLL, your exploit will only work on Windows 7. In my laptop right now, I'm on Windows 10. If I use a system DLL for my jump ESP, the exploit will only work for what?
Windows 7.
Okay, Windows 10, because I'm using Windows 10.
Right, exactly.
Now, what if I get my jump ESP from here?
Third party.
Huh?
From the third party, yeah.
From the third party. Can you keep service pack in the machine all you want?
Yeah, because it is not impacting that, it's impacting the third party.
Exactly. So attackers prefer third-party applications because the attack landscape is bigger, right? Because it can be Windows 7, Windows 8, Windows 8.1, Windows 10, right? If I use the third-party DLL. If I use the system DLL, then what am I stuck with?
We chose whatever version of that system.
Right. So we prefer to use the third-party DLLs. And you're going to realize that that's what attackers do as well. How many of you guys notice there's a lot of exploits for Java? A lot of exploits for Adobe, right? Why is that?
That's because you're using the third-party DLL.
That's right. It's third-party and it's everywhere. And I won't need to worry about what version of operating system you're running. Yeah?
Yep.
Okay, so what I'm going to do is I'm going to double-click on ESS Func. If you did this properly, it'll show up here as main thread module ESS Func. Your first instruction is going to be a push EBP. Did that work?
Just double click?
Yeah, you double click on ESS Func.dll.
Oh yeah, push. Yeah, okay. Yeah, I see that.
Okay, are you in main thread module ESS Func?
Main thread module is fine. Yep.
Okay, your first instructions are push EBP?
Yep.
Oh yeah.
Okay, good. What I'm going to do right here on the push EBP I'm going to right click. I'm going to push EDP. I'm going to right click and I'm going to choose the option search for command. Search for command.
Mm-hmm.
Does that work for you guys?
Yep.
Okay. The command I want to search for, all caps, is a jump ESP. JMP space ESP.
Mm-hmm.
JMP space ESP. Okay, is that working for you?
Yep. Let's just search it.
Okay, so I'm going to search for it, find. Okay, how many of you guys got this right here?
Got it.
You got a 625011 AF?
Yeah. Yep.
Okay, so that's a jump ESP instruction, right?
Mm-hmm.
What I want you to do is I want you to right click on it, choose the option breakpoint, toggle. Right click on it, choose the option breakpoint, toggle. When you do that, it'll turn red like this.
Mm-hmm.
Yeah?
Yep.
Okay. So is your debugger, does it still say running?
Yes.
Okay. What I want you to do is let's go look at script number 6.
Okay. Mm-hmm. Open the notepad. Yep.
Okay. Our distance to EIP is what?
2006.
So,
Okay. Immediately after that, we should have a what?
Jump
jump ESP.
to
Uh-huh.
Mm-hmm.
Now, did you guys see? Look how I wrote it.
Uh,
You see the 62,
uh,
the 50,
Mm-hmm.
the 11. Yeah. I wrote it backwards. You see that?
mhm.
And
Right.
the /X lets the computer know it's in what?
Hexadecimal.
Hack.
Does that make sense?
Yep.
Mhm.
Okay.
And
So I have 2006. Here's my jump ESP. So 2006 plus 4 is 2010. I've been sending 3,000 all this time, right?
right.
So that leaves 990 left, right?
Mm-hmm.
So I'm just going to make that all what?
All C's.
I'm going to make it all C's. Okay? So as you look here, you see how it all comes in? T-run,
Mm-hmm.
distance to EIP is 2006, right?
Mm-hmm.
Here's my jump ESP, right? You're overriding EIP with it.
Right.
And then my shell code is how many C's?
990.
And hopefully you'll go like this, right?
Yep.
And what I'm hoping is that this will be in ESP.
Mm-hmm.
That's the hope. So let's double click on script 6 and let's take a look.
Okay.
So I double click on script 6. Now how many of you guys saw that your breakpoint changed color?
It
It
did.
changed from red to black?
Yep.
Okay. Now, I'd like you to go look in your registers. What do you notice? What's in EIP?
Oh, it changed.
Is that the address of your jump ESP?
Mm-hmm.
So if you jump to ESP right now, what will you land in?
I'll see.
Uh-huh.
Wow.
So now you just replace the C's with the actual shellcode or the actual payload. Right-click on script number 7, edit it with Notepad++. See if you can see what we did. Is it the same at the start?
Mm-hmm.
Is the jump ESP the same?
Mm-hmm.
The only thing that's different is what?
Payload.
Yeah, so the payload, that's the actual malware that you wanted to run. It's the only real thing that's different, huh?
Mm-hmm.
So I'm going to do my debug. I'm going to restart. I'm going to hit play. Okay. Now, I want you guys to try this. Okay, try this. Good God, come on, man. I want to open a command prompt. Come on, brother. Work with me. Okay, so I got my command prompt open. I'm going to do netstat. ANO pipe find. Excuse me.
Bless you.
Thank you. So I do a netstat-ANO. And this is a pipe, not a colon. That's a pipe.
Mm-hmm.
Okay, the pipe is right above your enter key.
Mm-hmm.
Pipe find string 4444.
Okay.
Huh? When you do it, you should get nothing.
Nothing. Right.
Okay, so the netstat. So the goal of the netstat is to see if I have a port open. What port are we looking for?
444.
4444, right?
Mm-hmm.
And it's not open. Okay, your debugger is running, right?
Right.
Okay, now I want you to run script 7. I run script 7 one time. Okay, now if I go to my command prompt, if I up arrow and run it again, now what do you notice?
Port is open.
The
Please,
port's now open, huh? Now look at your debugger. Is it still running?
Yep.
Oh, mine is terminated.
Okay, is your port open?
No.
Okay, so go ahead and do a debug restart.
Okay. Debug. Restart. Okay. Play.
Play.
Run the command again.
Run script 7.
I'll run script 7.
Okay.
Okay. Here we go. Check it again. Nothing yet.
Then you do the netstat again.
Next start again. Nope. Doesn't come up.
Say what?
No, it does not
Okay.
detect.
So let's do a debug restart.
Okay. It said terminated. That's what it shows. Okay, so debug, restart, twice, play. Okay, now it's running.
Okay, now it's running. Okay.
Waiting for client connection. And
all right.
it does not on netstat does not show.
Okay, netstat does not show. Now let's run script 7 one time. Double click it.
Okay. Okay. Yep.
Okay. Now go back to the command prompt and run the netstat.
Nope, does not show. The debugger shows running.
Huh?
Oh, 2-4. My fault. Sorry. I put an extra 4.
Ah, checking a
Yep.
different port, huh?
Yay.
So do you now have that port open?
Yes. Mm-hmm.
And your application kept running, right?
Yep.
Okay, so now I want you guys to think of, how many of you guys hear people that talk about all this like Splunk and Syslog and ArcSight and all of this stuff, right?
Mm-hmm.
Right? Those types of products?
Right.
Okay, so now considering what you just saw, how many log events would have been generated? If you
Right here.
just ran script number 7,
Oh.
you just ran script number 7, the application executed a command for you, and then went right back on his merry way and kept on running.
Mm-hmm.
Did the application crash?
No.
No,
No.
right? This is one of the things that makes exploitation difficult to detect.
Mm-hmm.
Does this make sense, guys? Because like
Yep.
when the application misbehaves, hopefully the application would generate some sort of a log entry somewhere to let you know it's misbehaving,
Right.
right?
Mm-hmm.
If the application isn't configured with really verbose logging, so that we
Mm-hmm.
can go, hey, I ran something I'm not supposed to normally run, would you know that that happened?
Right.
No, this is why we tend to rely on things like antivirus and host intrusion prevention and all of that. And what they're looking for is they're looking for that payload injection. They're looking for the command shell. They're looking for the reverse connection out to the internet somewhere, right?
Mm.
They tend to look for the result of the exploitation, not the actual exploitation.
Mm. Yeah, because all these changes happen and nothing was generated based on the
Not
application.
exactly.
Mm-hmm.
So catching a hacker right at the moment of exploitation is actually kind of difficult. What we tend to catch is what the attacker does once the machine is compromised. Does he start
Right.
sending spam? Does he start port scanning? Does it start doing callbacks to somewhere else on the internet? Does that
Mm-hmm.
make sense, guys?
Right.
Right? So as long as you guys understand that, like now that you're starting to see how the exploits work, right? We're starting to get a feel for our world. Okay, so let's wrap this up, okay? I want
Okay.
you guys, how many of you guys notice there's another script in there?
Oh, the vulnerable server.
Yeah?
Yep.
Okay, let's right click on that and let's edit it with what?
With no power plus flash.
Ah, okay. All right, we have someone on the phone?
Not me.
Okay, so here you can see that change this to Metasploit, right? And now what it's telling you is if you want to put this in Metasploit, you copy this file and you stick it here.
Mm.
Okay? All right, so we start with requiring what?
Yeah, Metasploit core.
Okay, is this very much like what we've seen in other Metasploit scripts?
Yep.
Okay.
What
And
does the
then
core mean?
core is just the core components of Metasploit.
I see. Okay.
Okay.
Mm-hmm.
Then we build a what?
Class.
Okay, we're going to call the class what?
Metasploit 3.
Okay, and what components are going to go into it?
Metasploit and remote.
Good. Okay, and then what specific stuff do we include?
Specifically exploit remote and the TCP
Good
connection.
job. Okay. And you remember the def initialized? That's all the metadata, right?
Yep.
Okay. So that gives us what?
Name,
Uh-huh.
description.
See?
Mm-hmm.
Okay, now you're going to see a real tricky part. Okay, one of your options is an option called exit function.
Mm-hmm.
Okay, when you have an exit function, what that means is as the exploit is happening, how do you want us to exit out of this process? Do you want to exit as process? Do you want to exit as thread? Do you want to exit as SEH, structured exception handler?
Mm-hmm.
And the easiest thing to do is there's only 3 basic exit functions. Whatever makes your exploit more stable is the one you're going to choose.
Mm-hmm.
Okay? So if you run your exploit 2-3 times and you notice, man, my command shell, it only works half the time.
Mm-hmm.
You might change it from process to thread,
I see.
right? So in other words, everything here is about stability, okay?
Mm-hmm.
Okay, payload. What do you guys notice for payload?
Space fill up for 800
Yeah,
characters.
so you guys notice for the shellcode I had what, about 990?
Mm-hmm.
Okay, so to make sure it's comfortable with the space, I just told it, hey, don't use a payload that's more than what?
800.
Uh-huh.
Very equal. Mm-hmm.
Right, so, your payload should be pretty comfy, 800 bytes, it should be okay. What I say for bad characters not to use?
Yeah, so if 00 and 20 they're bad, don't include it.
Okay, now with most clear text protocols, like
Mm-hmm.
HTTP, FTP, clear text protocols usually don't like a null, 00,
Mm-hmm.
right? They usually don't like a null. And then what you're going to do is you're just going to look for other characters that the application does not like, okay? So what you're going to say is, hey, when you build a payload, don't build payloads with this.
Mm-hmm.
Okay, what's our platform?
Windows.
Uh-huh. Does this guy look familiar?
Yeah.
Okay.
1150 62. Yep.
Uh-huh. You'll hear people call that a RET. It's short for return address.
Mm-hmm.
Okay? Because when EIP returns from a function, that's EIP, right? The return
Mm-hmm.
from the function. So it knows where to pick up and keep executing. So you'll hear it for kind of nerd slang called a RET.
Mm-hmm.
What do we have for port?
999.
Uh-huh.
9. Mm-hmm.
And then right here, there's your 2006.
Mm-hmm.
And then your 2006 plus the target return address, right? Which in our case is 62, what is it? 625011AF, right? The header
Mm-hmm.
for it is trun. So you just put the header plus everything and then run it.
Mm-hmm.
That's literally it. That's literally it.
Wow.
So this is that process that the attacker goes through. Now, you could go to exploitdb.com
Mm-hmm.
slash shellcode. exploitdb.com slash shellcode. Now, when you look at the shellcode, what are you noticing that they generally tell you in most of your shellcode?
The numbers are
Size.
right. So,
Yeah, how big it is, huh?
mm-hmm.
Because you don't want shellcode that's too big for the space that you have. So we have how much space?
162 and
No, I think we were what?
990?
There you go.
9, yeah.
Yeah, we were like 990, huh?
Mm-hmm.
Okay, so here's some that I thought was really cool. I'll give you guys this link. Okay, now what does this payload do?
Creates administrative user
Uh-huh.
and adds him to remote desktop group.
Uh-huh.
Enables remote desktop from the register and stops firewall. And auto starts terminal service. Wow.
Yeah, that does a lot, doesn't it?
Yep.
Yeah, you're like, okay, huh?
Serious stuff.
Yeah, serious stuff, but what do you notice?
Probably.
Size
Mm-hmm.
is big.
That's a really big payload, yeah?
Mm-hmm.
So these
No,
are
that.
those things that you start to realize that hackers have to deal with, right?
Mm-hmm.
Because it may be very, very cool shellcode, but, you know, does it fit into the space that I have? That make sense, guys?
Right. Now, does it make it different? Is it like if it's is it 64-bit or 34? I mean, 32
Oh
or
my God,
64?
yes it does. Yes, it does.
Mm-hmm.
So, what do you notice?
Ah, that's made for 86 and 64, 32.
Uh-huh. Also, what do you notice?
It might be x86. Okay.
Okay. The shellcode is platform specific.
Mm.
The shellcode is platform specific. So if you're going to run it on mobile, you need ARM shellcode, ARM.
Mm-hmm.
You see?
I see. Okay.
If you want to run it on like a Windows tablet, you need RT shellcode,
Mm-hmm.
right? So
Mm-hmm.
all of these, the exploit is always the same, but when you need to port the exploit to a different platform, the shellcode or the payload needs to be for that platform.
Mm-hmm.
Okay, I got this one thing and then let's take lunch, okay?
Okay.
Oh, jeez.
Oh, don't click.
Can't stand when everyone wants to protect me when I don't want to be protected, huh?
Oh, it's Joe. Let it pass.
It's kind of like, I can do it myself. Does anyone have like little kids? The little kid's like, no, I want to do it, right? You're like, okay, tie your shoes. Okay, this is serious, huh? Okay, you tie your shoes. Go ahead. Ignore the warning. Okay, so okay, I want you guys to look at this. Can you tell me what this is? This is an exploit. What did they do? What are all of these?
Those are wow.
Different versions
Those
of
are
Linux.
languages. Local.
Languages, uh-huh.
And they have a different service pack.
So what's the difference between the system DLL and the third-party DLL? You remember that, guys?
Yeah, it is. System is platform specific, and third party is just
It'll run anywhere, right?
anywhere, right?
Okay, so this is probably all jump ESPs, huh?
Mm-hmm.
So these are all the different jump ESPs, but what did the attacker have to do? For each system, he had to load that system and find that jump ESP address for that particular platform.
Right.
Does that make sense?
Mm-hmm.
So when you hear people talking about porting an exploit or changing the target, this is what they're talking about. Now that you know how to do it, right, you would just say, okay, well, please get me the Spanish version of the software. And you put it in your debugger, and the process is the same, huh? The
Yep.
distance to EIP is going to be the same, right?
Mm-hmm.
And the only
Right.
thing is when you look up your jump ESP, the address is going to be different,
Right.
right? But the address is going to be different if it's what kind of DLL? System or third party?
System and third party. Yep.
Yeah. Does that make sense, guys?
Yep.
Okay. All right, guys. I say let's stop. Let's grab some lunch.
Oh,
You guys okay with an hour and 15 again?
Sounds good.
Okay. I'm sorry that we pushed
Yeah.
so hard without a break. You know, normally we take a break like every hour.
No, this is good
No
stuff.
problem.
Okay. But is it kind of making sense?
Oh, you're making perfect sense now.
All right.
Yep.
Okay, guys. So let's take our break. Let's come back at 1, okay?
I won. Okay.
All right, good buddy. See you in a little bit.
Sounds good.
So I'm gonna start the recording. Okay, guys, welcome back from lunch. All right, so this time we're gonna start with shell coding, specifically with MSF Venom. So what we want to do is we want to be inside of our Metasploit directory. Okay, so you just want to cd into that Metasploit directory. Okay, so it's /home /strategic sec /tools /Metasploit.
all right.
Okay, so once we're in here, we want to get familiar with something called MSF Venom. So what we're going to do is we're just going to run line 1700, MSF Venom. Now what tends to happen is most people go to that website that I showed you before, exploitdb.com/shellcode. And this is how you get shellcode, right? Now, it was traditionally called shellcode because what it did was it was assembly code that opened a command shell. So you broke into a machine, you ran this assembly code that opened a command shell, thus the name shellcode. Now today, we tend to call it a payload. So you'll hear people talk about, oh, this is the payload that the malware executes, right? So today we call it a payload because it can do so much more than open a command shell. It may, for example, do something like this, where it's a download and execute. It may read a particular file on the file system, like this one reads the etc password file. It may add a user account, like the one that we looked at before. It may install something like VNC and give you an actual desktop. It may pop up a message box, right? It may start a sniffer. It can do all kinds of different things. So what you end up with today is payloads. Now, the problem with using shellcode from somewhere else on the web is there oftentimes is signatures for that shellcode. So you may want to use your own generated shellcode. One, you may be trying to bypass like an IDS signature somewhere. That could be an option. Two, maybe the shellcode on the web doesn't do exactly what you want. Maybe it's close to what you want, but it doesn't do exactly what you want. Like maybe you don't want it to read the password file. Maybe you want it to read another file, for example, whatever that case may be. But in other words, whatever you're finding on the web doesn't do exactly what you want. So you might say to yourself, okay, I need something that does this specific thing. So by running it in Metasploit, you're going to see that we have a ton of payloads. Like it's just not even funny, the sheer volume of payloads. So let's say, for example, you need a 64-bit VNC inject payload where it injects via DLL injection. It's going to add this VNC remote desktop payload, and you want it to come back to you. Maybe you want it to come back to you over HTTPS, as an example. You may want something that uploads an executable over IPv6, right? So you want it to upload an executable and communicate with you over IPv6, right? There's just so much. Like we can go through this stuff for days. There's a lot of payloads. There's just so many payloads. So are you guys seeing here how we've got payloads for AIX Unix? They've got payloads for Android. They've got payloads for BSD, right? Spark Platform BSD. Now, if you remember earlier, Roland asked a really good question. He was like, well, what do I do if I have a 64-bit platform? Well, this is exactly what you need to know. right? When you're writing an exploit, your exploit needs to run on the target platform, the appropriate target platform. So you have to make sure if I'm attacking Spark or MIPS or ARM or x86 Linux or 64-bit Linux, you have to have the correct shellcode for the platform. The exploit is the same. All the distance to EIP and all that stuff is completely the same regardless of the platform. The payload is platform specific. So you may have to swap out the payload to work on different platforms, right? Which is what you're looking at right here, right? We've got, old command Unix style payloads where it runs with awk as an example. This is really old school tricky stuff that we used to do back when I was hacking in the 90s. Awk, sed, awk, and gawk, and using that to build like tiny rootkits back in the day. That's old stuff. But you see that they've got it here, where they've got it where it works with Lua, where it works with Netcap, where it works with Node.js. Like, there's so many different tricks you can do here, right? It's going to connect back to you with a shell that's in Ruby, as an example. It's just a lot of tricks here. So whatever the case may be, you're going to try to get a payload that does what you need for the particular situation that you're in. Okay, so now let's see if we can build a really simple payload. So in this case, you're going to MSF Venom, right, -P for the payload, and then what you're going to say is Windows, interpreter, reverse TCP, and then you specify the L host. It's going to output to a file, and the file that it's outputting to is an exe file. So we did this yesterday when we were doing this with Bail, right? You didn't see on the back end, this is basically what Bail was doing, where it was building an executable for us. So let me go back to Notepad. Let me build this up. Okay, and then what I'm going to do in lhost is I'm going to set 192.168.10.128 output into an exe. We'll just let it run. Okay, and there's your binary payload. Let's see. Oops, looks like it didn't run. Oh, it didn't run. I think I must need to give it a file name. Let's see. Let's try that again. No? Huh. No platform was selected. Oh, I didn't specify a platform. No encoder. Okay. Okay, but it built the file. Okay. All right, so I just needed to do the output. Okay. So I should have told it x86. I should have specified the architecture. right? And then I should have said, hey, use these bad characters. What I did was you should tell it what bad characters, and you should tell it what platform. Okay, this is the encoder to use. Okay, now we talked about how to build an encoder. Shikata Ganai is probably the most popular encoder you're going to find out there. You're going to find that this is probably the most popular encoder. It seems like the whole world likes to use Shikata Ganai. Shikata Ganai is a polymorphic encoder. So every time that your payload runs, when it gets passed through the Shikata Ganai encoder, it's going to be different every single time that it runs. This is one of the reasons why people like it so much. Come on, computer, catch up to me. Did I break the internet? Oh, I guess we don't need to see that link now, do we? Okay, so this is the old way of doing everything. Back in the old days, last year, we used something called MSF payload. And MSF payload is how we generated payloads. Then we ran it through something called MSF encode. Today what's happened with MSF Venom is you've combined the two together. So MSF Venom is now the payload generator and the encoder. And what was it? What was it, January of last year? Yeah, June 8th. June 8th of last year. So everything now is MSF Venom. So if you're going to be building payloads that go into your exploits, this is what you're supposed to be using. Sorry, I lost my place.
$17.04.
Thanks, good buddy. I really appreciate that. Way to help out us old guys. Okay. Here's another one that could be interesting, right? So the next one is modifying an existing binary. So let's say, for example, you have calc.exe, and in this case, what he's doing is he's injecting, excuse me, he's injecting this into calc.exe, outputting it to a file and saving it as new exe. So just kind of showing you what some of these things can do, right? So running it through Shikata Ganai, the -I is telling you how many times you want it to be encoded. Okay, now we haven't really covered NOP sleds, haven't really covered some of these other little nuances with exploit development, and that we just really didn't have enough time, to be honest. But suffice to say that when you're building payloads, let's take a look at the payload that we've been messing with. Something I did not explain If you remember when we did our exploit, we came in with trun, our distance to EIP, which was 2006. Here was our jump ESP. Now when you jump to ESP, you guys notice that you actually land here and then slide into your payload. Okay? These X90s are called NOP, short for no operation instructions. So here we've got 16 NOPs. We're going to land in those 16 NOPs and then we're going to slide right into our payload. The reason that you do this is you provide this for padding effectively so that when you land, you have kind of a nice, safe place to land. One of the things that might happen is there might already be something in ESP at the time, and you potentially could overwrite whatever's happening in ESP at the time. We have another method of doing this called a stack shift or stack adjustment. So what's happening is you have something, let's say this is ESP right here. You want to take whatever's happening in ESP and move it. So you'll often see that in exploits where they have a stack adjustment in it. And again, all that's trying to do is you're just trying to say, okay, what I want to do is I want to make sure that I move stuff out of ESP, because ESP is where a lot of operations are performed. So you want to move stuff around and give yourself, when you land in ESP, a nice soft landing place without interrupting things. So you're going to hear people talk about the term professional grade exploits. So exploits that go into frameworks like Metasploit and Core Impact and Saint, they're what are called professional grade exploits. In other words, people are using things like the exit function that I told you about earlier to try and make it more stable. They're using things like NOP sleds, and they're using things like stack adjustments so that the exploit stays more stable. The goal is to have an exploit that works 10 out of 10 times, that does not adversely affect the application. Because if you think about it, you're taking a running program and making it go in a completely different direction. So the whole thought process behind professional grade exploitation is to use frameworks. The goal is to get away from using websites like ExploitDB, because these exploits are just written by just people like you and me. There's no real validation. There's no real testing to ensure that the stuff that you're running off this website isn't harmful to you, right? You could be installing malware. Now, ExploitDB has taken some links to get around that. Do you guys see right here where they have these check marks? What that's telling you is that the team from Exploit Database, they have verified the exploit. Okay, in other words, they've downloaded the vulnerable software, they ran it, and they found that they got it to work. You'll see here, if it's got this link, this means that they've got a link to the vulnerable software, and you can actually download it.
So any of this can be imported to Metasploit, and from there, just change the code, and then you have to compile it, or
Can you say it one more time, buddy?
No, I'm saying like any of this code, any of this exploit here, you can just import it to Metasploit and change it accordingly, or you got to compile it and get it
Okay.
ready, or is something that's already, as you said, is verified. That's it.
Okay. Any of the ones that say Metasploit is the author, you just have to wait for the exploits to come from the update in Metasploit. So like if it says Metasploit is the author, it's already in the Metasploit framework. You don't need to update, well, you may need to update, but you don't need to grab it off here.
I see. Okay.
Okay. Now, if we have some, let's say we have one from here, and let's say we go look for an FTP server, RTZ. Okay, I'm pretty sure that PC man. Let's take a look at this one. Okay, here's one that you guys can handle. Okay, so if we look at this, let's see if we can read this exploit and let's see if we can figure it out, okay? All right, so what language is it written in, guys?
Python.
Okay, it's written in Python. Okay, the vulnerable software is what?
Version 2.0.7 FTP
Okay.
server.
Yeah, so it's this PCMan FTP server software, version 2.0.7, exactly. Okay. And it's tested on what?
On Satisfactory.
Okay. All right. So if we go here, you see how here you're allowed to download the vulnerable application? Okay, so you could grab the app right here, and you could test this yourself. Okay, now he's not using MSF Venom. What did he choose to use?
Metasploit.
What's the predecessor to MSF Venom?
Oh, the payload.
Yeah.
Payload.
Yeah, so MSF Payload, today we use MSF Venom, but this would be the old syntax, right? So he's going to create a Windows shell, and the shell is going to run on what port?
9988.
Good job. Okay, then what are his bad characters? What characters does he not want in his shellcode?
Null.
Good job. That's a null. Good. Yep, 0A and 0D. That's probably a carriage return and a line feed, probably. Okay, really good job. Okay, so now as soon as he did that, this just means tight C, like C style. Yeah, see, it's not even in there anymore. Okay. All right, so you would run that, and it would generate this, right? Okay, so his buffer is 90s. Do you remember what these are?
That's the Nops.
There's your nops. Good. Okay. And how many of them is he creating?
30.
30.
Good job. He's creating 30. And then that shellcode that he created above goes where?
Goes to
It's just right after it, huh?
right. Mm-hmm.
So he's putting his nops and his shellcode together. Okay. Now he's got 77C35, 77C3, 54, 59. That is a push ESP ret. A push ESP ret is the same thing as a jump ESP. It's kind of like 5 plus 5 and 6 plus 4. Right? So, did you see that he wrote it backwards just like I taught you?
Mm-hmm.
See that?
Yep.
So look what he calls it. He calls it evil. It's A times what?
2008.
Is that probably your distance to EIP?
Very possible.
Yeah, it's starting to look kind of like the exploit I just showed you, huh?
Yep.
So there's your distance to EIP. This is your push ESP ret, which is basically a jump ESP equivalent, right?
Mm-hmm.
And then immediately after that, he's got buffer, which is your nops,
Mm-hmm.
which is your 30 nops and your shellcode together, right?
Right.
That's what he's putting right there. And then he says C times 888 minus the length of what?
For the buffer.
Okay, the reason that he does this is because he wants to give you the opportunity to swap out the shellcode anytime you want. He knows he's got after buffer, he's got 888 bytes left, right? So now what he's doing here is to make sure that the padding is the correct size. He just subtracts it from whatever you have for the size of buffer. Okay, does this look familiar?
Yep.
Okay. Now raw input. Someone had a question? Okay. All right, now raw input is just how you prompt. See how it says enter host, and then it'll throw a 21, so that way you enter in the IP address, and then it'll throw a port 21.
Mm-hmm.
And then he just says, okay, he sends the username, he sends the password, he sends the put command, because that's obviously what it crashes on, and then what?
Evil. That's the code.
So are you seeing that this is very much, very, very much like what you guys ran into?
Yeah.
Very similar, huh?
Yeah.
Very, very similar. Okay, so now you guys would see that you just use MSF Venom to generate these payloads, and I think you guys are going to start to see, like, here's an example of the guy using MSF Venom to generate his payload.
Mm-hmm.
Okay, so it's Windows, shell, he specified his lhost, he specified his port, then he had to turn around and he had to tell it, here's my bad characters. And that's a huge list of bad characters, isn't it?
Yeah.
Mm-hmm. Then he outports it as fruby. Do a dot slash right there. Change this to a 10. 128. There you go. Not too bad. So are you starting to see that you could make the shellcode however you want? Like you see how it's encoding it? One iteration of what?
86, that's about right.
Okay. All right. Now the Shikata Ganai didn't work, so it encoded it with x86 call for D-word XOR. Right? And that actually worked. Now what's the size of my payload?
52.
Uh-huh. And that's it. That's really it. Okay, now let's see if I can find one where they've already taken it and put it in Metasploit for me. And then we'll stop there. ILDN. Okay, that's the one I just taught you. That's a directory traversal. Okay. All right, so let's go through this one. That's it's an SEH overwrite. You guys haven't learned that yet. Okay. I haven't taught you guys an SEH overwrite, so I won't cover the other one. All right, so here he's making MSF Venom. What's he making it generate, guys?
On the calc.exe file.
Right. So what you're dealing with right now is this is not going to open up a command prompt. What this is going to open up is it's going to pop calculator. Like the Windows calculator is going to start up. Like literally it'll be that. Okay. All right. You get a lot of people who write exploits that try to do calc. The whole reason is because once you've done your jump ESP, it's going to run anything now, huh? So if you want it to run Notepad, will it run Notepad? Yeah. You want it to run calc, will it run calc? Yeah. You want it to run a download and execute or a bind shell or a reverse shell or a sniffer or add a user. It doesn't matter what the payload is. The payload is not the exploit. The exploit is that jump ESP, right? You overwrote EIP with an instruction to go somewhere else. That's the exploit. The payload is just what you want the exploit to accomplish after you have the ability to execute something. Okay? Okay, so this one is really simple code. It just pops calc. A lot of people pop calc because it's so small. Right? It's just really small. So I haven't taught you guys a structured exception handler override, but that's what that means when it's SEH. That's what it means, structured exception handler. But instead of distance to EIP, you're doing distance to structured exception handler. So there is his distance to structured exception handler. His next SEH is going to be short jump 13, nop, and then it's going to be this instruction right here for SEH, which is a pop return. I know that's like a bunch of gobbledygook, but you'll understand when I do your next class. And now, how many nops?
22.
Plus the shell code. So as soon as you guys see below that, is the socket code any different?
Right.
Socket code is pretty similar, isn't it?
Yep.
So now, when it's time to take that same exploit, I didn't want to do this way, but I can show some of it. The setup of an exploit is always the same, right? You're going to use the Metasploit 3 class. You're going to put into it what's required for the exploit that you're doing. In this case, it's an FTP exploit, and he's doing a structured exception handler. We would need probably a whole day, because I only taught you a Stack Overflow. Your very next type of overflow is a structured exception handler. We'd need like a whole day to cover this. And then after that, you've got heap spray, and then after that, you've got like off by ones and depth bypass and ASLR. So when you hear guys talk about the exploit development class, it's 5 days of the kind of stuff that we did this morning before lunch. So I'm sorry, I just didn't have enough time to teach structured exception handler. But everything else that goes into the exploit is the same. How much space, right? Bad characters, target platform. Okay. The return address is this pop ret. And then how you connect to the target. You're going to keep seeing this, that the exploits are very much like what I showed you with the auxiliary modules. How many of you guys remember day before yesterday, the auxiliary modules were like, once you got kind of the feel of one, they were all kind of cookie cutter, weren't they?
Yep.
Yeah, and then you just kind of swap out the appropriate components. So you find an exploit that's really similar. Like, okay, I'm attacking FTP. Let me go find an FTP exploit. I'm attacking a web server. Let me go find a web server exploit. I'm attacking a mail server. Let me go find a mail server exploit. And then you just kind of swap out the attributes, the return address, the offset, the bad characters. You know what I mean? And then boom, you've got a brand new exploit. So it's a pretty extensible framework. I think you can do so much with it. You can get auxiliary modules written quickly. You can get exploits written quickly. I mean, you can really tune Metasploit to do whatever you want. We learned how to evade antivirus using Veil. And it's just a lot There's a whole lot you can do. I mean, there's just so much. I was going to cover taking exploits out of the framework and converting them into standalone exploits, but you know, it took us a couple of hours to do a regular exploit this morning. It will probably be the same amount, 2 to 3 hours to take one out of Metasploit. For those of you that are interested, I can give you a video of the last time I taught it.
Sure, I'm interested.
So for those of you who are interested in that, I'll give you guys a video of the last time we taught it. I'm thinking I'm going to wrap up today because I just don't have enough time to cover this last section. Like, I need probably about 4 hours. So the taking exploits out of it and building the modules, I need a couple. I probably could do it in about 3, but that push us a little late for a Friday. So, okay, so now I need to build slides for you guys, videos for you guys, and then I'll keep this paste bin. Yeah?
Yep.
Okay, and then you guys will keep this, and then I'll email out everything to you guys.
Excellent. Are we
All
going to
right?
send the email for a link and get it from there, or I guess?
Well, as soon as I upload these videos, it's gonna take me another hour to convert this video.
Okay.
So it's gonna take me another hour to convert this video, and then I'll upload it. That'll probably be another half hour. And then once the videos are completely uploaded, I'll give you guys links to the videos, the paste bin, and the slides.
Excellent.
Fair enough?
Fair enough. Yep.
All right. Hey guys, let's wrap it up. I want to thank you guys so much for doing the class with me today. I really appreciate you taking the time. And when I send you guys the email, you guys will have all of my contact information.
Okay.
So I'll put some extra videos of previous classes that I've taught in this bundle that I send out to you guys, okay?
Excellent. Appreciate it.
No problem.
Thank
So
you,
I'll
Joe.
throw in some exploit development stuff. I'll make sure that we throw in everything you need, okay?
I appreciate it, Joe. Thank you. Great class, man. Appreciate
Hey,
it.
thanks a lot, guys. I really appreciate you guys, man. I really appreciate it. It was a great time for me. All right, guys, everybody take care. Uma, relax, buddy. I'm going to give you the mother load, man. It's coming, okay?
Okay.
Thank you, Joe. And also, if any class I can attend yours, Joe, it will be great.
Thanks, buddy. I really appreciate it.
You really interested me in this.
Thanks, man. I really appreciate it. Okay, guys, let's get it going.
All
Thank you,
right.
Joe.
Sounds good, Joe.
You
Thank
take
you.
care, guys. All right.
Thank you.